Experiment number 9, titled amines, is an experiment where we take primary, secondary, and tertiary amines and we use what's called the Hinsberg test in order to determine or test their functionality. Depending on the solubility of the resultant compound, we can determine whether it is a primary, secondary, or amine compound. And so when we have an unknown amine, we'll be able to use this test in order to determine that. We're also going to be looking at acetylation, which is a organic process used a lot in synthesis in order to protect an amine functionality from being oxidized or reduced during reactions. So in our 3 test tubes, we have 10 mils of water and 2.5 mils of the 10% sodium hydroxide solution. And now I'm just going to add the benzene sulfonyl chloride, so it's just 1 mil of that. For this experiment, you don't need to measure things out precisely with a graduated cylinder. Just make sure you use the pipette bulb. You can say that the pipette bulb is about 1 mil. So just 1 squeeze will be enough for 1 mil. So maybe you can see when I'm adding the benzyl sulfonyl chloride here that the density of it is much greater than the density of water, and so it's sinking down to the bottom here. So if I swirl that around, you can kind of see there's a little layer there. Oh, and there's the rest of it falling down. So the benzyl sulfonyl chloride is sitting at the bottom. Now to each of these 3 test tubes, we're going to be adding our 3 different amines. So for the first test tube, we're going to add the primary amine, which is aniline. So we're just going to add that on top. And you can see that with the amine, it's actually just floating here. And if we give that a little tap, it'll mix a little bit, but it's not mixing with the water. But we need it to get down to mix with the benzyl sulfonyl chloride. So if we give that a good shake, and you can see right away that there's a reaction occurring. And you can see down at the bottom here, we've got a lot of solid formation settling out in the bottom. So here we do have a reaction on the primary amine. Now for the secondary amine, we're going to take the N-methyl aniline, which is a secondary amine. I'm going to add about 1 mil of that. You can see that the density of this amine is pretty light, so it likes to sit on the top. So we need to mix it with the bottom there. And you can see that my mixing, it's really hard to get it down there, so you need to mix this one really well. So there you can see a lot of powder formation, and it's not completely mixed yet, but that's pretty good. And so there is some solid precipitate. You can also feel that this reaction heats up a little bit, so you know that there is a reaction occurring. So I'm just going to put that down, and we'll let that try and settle down. Now for the tertiary amine, we're using a triethylamine, and we're going to put that into the 3rd test tube here. And you can watch as it's going in, but there's not really much happening. It's just kind of sitting there on the top. And if we mix this one really well, just like the other, you can see that there's a lot of bubbles, but it's not a solid. You'll be able to see that. I don't know if you can see it on the camera, but there's tiny little bubbles, but it's really just the amine mixing with the water. But there's no reaction that's occurring. So this one, no matter how much you shake it, you're never going to get a reaction. So the amine's always going to settle back up to the top, and you're always going to have the benzyl sulfonyl chloride at the bottom. So for the next part of the reaction, we only need to test the first two compounds, the primary amine and the secondary amine. And we're going to do that by decanting off the top solution. Here you can see that there's a little bit of unreacted amine here, but that's okay because all we really want is the solid out of here, and that will be okay. So we're going to decant off the top. We'll just grab a waste beaker and remove the solution. You can see that there's all that solid there. And what we're going to do is we're going to add some of the 3 molar NaOH. And as indicated in your lab manual, adding the base should dissolve the solid that's in here. So it's going to deprotonate the compound and allow it to dissolve. So you can see just with 1 pipette of base that all that white powder that was there is pretty much dissolving back into the solution. And that's what a positive test for the primary amine would look like. And for the secondary amine, you can see here that all of the powder solid is actually still mixed here. So it's rather difficult to separate out. But if we decant off some of this, we'll see if we can get this to work. So again, in the garbage, we're going to kind of take off the first top part. There's going to be a lot of solution left over in there along with the solid. But if we separate it out, we won't have to add as much base to get it to go. So we'll try this one. And we're going to take the base. And so you can see that the powder is not really dissolving back in, even if we add a bunch of base in there. So it's still staying solid, and so that means that even after adding the base, we have an insoluble product. And so that's how you can tell the difference between a primary amine and a secondary amine. So for part 2, the acetylation, we're going to be taking aniline and the acetic anhydride and adding it into another test tube. So we only need 1 ml of each of those into this test tube. So we're just going to let this reaction go just to mix, and we're going to leave it into an ice bath for a few minutes. So while this is cooling down, we're going to take another test tube with 0.5 grams of aniline hydrochloride, and we're going to be adding 5 mils of water. There. You can see that it still remains a solid there. And then we're going to be adding a 1/2 ml of the acetic anhydride. And for the 1/2 ml of acetic anhydride, you can just use kind of a half squeeze of the pipette bulb. You don't need to use a full one, and you don't need to measure it with the graduated cylinder. It doesn't have to be that precise. And we're just going to add that in there. And then we'll just give that a shake. And after we've shooken that solution, we're just going to be adding the sodium acetate here. So we already have this measured out. We're just going to add that into the top of the test tube here. And then again, we'll shake it up. You can see right away that there's a lot of solid forming there. You can see that it's very thick. There's a little bit of solution in there, but it's mostly chunky. So you'll want to write down some observations of how the hydrochloride actually reacts much differently than just the regular aniline. So after a couple minutes, you'll see that you are starting to get a lot of solid formation on the top here. It's not solidified all the way through yet, but you can see that it's definitely going there. So just leave it a little bit longer, and it seems to be going there. You're going to still have a little bit of solution, but you'll have your compound to isolate. So now all you have to do is decant off any liquid that you have, or dry them off on a filter paper, and then you'll have some compound to analyze. And write down the different crystal shapes that are in the two different compounds, and then you'll discuss why they are different and how they're different. And that's pretty much it for the lab.